How are you, my friends? This is Calculus 1 solved questions, and in this video, we will use Rolle's theorem and mean value theorem. This is part 1, and you can expect, as usual, part 2 and maybe more. Question number 1, given the function f of x is equal 4x squared minus 20x plus 29, which is defined on the interval 1 to 4. Find the number C that satisfies the conclusion of Rolle's theorem. These questions are coming from lecture number 16. You can check if you like. First, we see that this function is continuous. This is a parabola on the graph. It's continuous on 1 to 4 closed. It is also differentiable on 1 to 4 in the open interval. If we need to check f of 1, I put it here on this side. F of 1, replace 1 in the function, you will get 13. And if you need f of 4, also replace 4 in this function, you get also 13. So we see f of 1, f of 4 is equal to 13. So these 2 points, 1, 13, 4, 13 on the same line. So we can say that the conditions of Rolle's theorem are satisfied here. And then we look at the derivative now. F prime will be 8x minus 20. Put f prime at c is equal to 0. So we get 8c minus 20 is equal to 0. Find c, it will be 20 over 8, which is 5 over 2. So at this point, this is c equals 5 over 2. We have a tangent line, horizontal, and parallel to this line passing through 1, 13, and 4, 13. Look at this function now, 1 minus cube root of 2 minus x squared, which is defined on the closed interval 1 to 3. Find the number c that satisfies the conclusion of Rolle's theorem. Now note that this function f of x, 1 minus cube root of 2 minus x squared, is continuous on this interval, closed interval 1 to 3, because this is a cube root function with some shiftings. Now, is f differentiable? We have to check that between 1 and 3 open interval. F of 1, if you replace 1 in the function, you get 0. F of 3 also, you will get 0. So conditions 1 and 3 of the Rolle's theorem are satisfied. We have to check condition number 2. Let's find the derivative, f prime. The derivative of 1 is 0, minus 2 over 3. 2 minus x to the power 2 over 3 minus 1 times minus 1, the derivative of the inside here. You see 2 minus x, the derivative is minus 1. So we have plus here 2 over 3 cube root of 2 minus x, because this will be 2 over 3 minus 1. So it will be minus 1 over 3. Now clearly, we see f is not differentiable at 2, because if we replace 2 in the derivative f prime at 2, it will be undefined. So the function is not differentiable at 2, and 2 is between 1 and 3. So the conclusion here, there is no c, because Rolle's theorem here fails. Let's look at another function here, f of x square root of x minus 1, defined on the closed interval 2 to 5. Find the value of c that satisfies the conclusion of mean value theorem. Now we have to check the conditions here. F is continuous on this. This is the square root of x minus 1. F is differentiable from 2 to 5, because the derivative here will be 1 over 2 square root of x minus 1. So at every point from 2 to 5, it is differentiable. F of 2, replace 2 here in the function, you get 1. F of 5, you get 2. Put here 5 minus 1, 4, square root of 4 is 2. Now, the mean value theorem, we have the formula here, f prime at c is equal f of b minus f of a divided by b minus a. Just put the numbers there. Put c in the derivative, 1 over 2 square root of c minus 1. F of b is 2, f of a is 1, and b minus a is 5 minus 2. Simplify all that. This is 1, this is 3, cross multiply, divide by 2, then you square both sides here. See, x here is the same as c. When you are finding, you can write x, you can write c if you like. And then square both sides, you get c minus 1 is equal to 9 over 4. Take 1 on the other side. So c will be 13 over 4, which is 3.25, just between 2 and 5. It should not be in the middle. It can be any number there. So what is the conclusion now? The line through the points, this is a point 2, 1 and 5, 2, is parallel to the tangent line at the point 13 over 4, which is the c here, the x value, and then the y value 3 over 2. How do we get 3 over 2? Take c 13 over 4, replace it in the function here. You see, square root of 13 over 4 minus 1. Simplify that, you will get 3 over 2. So this is f of 13 over 4. Question number 4, given the function x minus 1 all to the power 2 over 3 defined on the closed interval 1 to 2. Same question now, find the value of c that satisfies the conclusion of mean value theorem. Same thing. The function here is continuous on 1 to 2. Differentiable between 1 and 2 open. F of 0, f of 1 here. So if I replace 1 in the function, it will be 0. F of 2, it will be 1. Just put the formula there for the mean value theorem, f prime of c, f of b minus f of a divided by b minus a. Put the numbers there. Simplify the equation. You get cube root of c minus 1 is equal to 2 over 3. I did not mention the derivative here because it's so easy to find f prime and then apply the mean value theorem, f prime of c. I think you know that. Cube root here of c minus 1 is equal to 2 over 3. Cube both sides, you get c minus 1 is equal 8 over 27. Take 1 on the other side, so it will be c equals 35 over 27, which is almost approximately 1.29, which is between 1 and 2. So this is the c. Take 35 over 27, replace it in the function here, in the function itself, f of 35 over 27. So you will get 4 over 9. So I can just say the conclusion here, the line through the points 1, 0 and 2, 1 is parallel to the tangent line at the point 35 over 27. This is the x, and the y value 4 over 9. For more questions on Rolle's and mean value theorems, you can visit the lecture number 16. And for more questions on Calculus 1 in general, you can visit the playlist Calculus 1 Solved Questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.